High above our planet, two of the world's most advanced space planes are redefining what's possible in orbit. The US X-37B has already traveled more than 1 billion miles and keeps breaking records with new technologies, while China's experimental Shenlong spacecraft is proving it can stay aloft for months at a time. These developments aren't just about science. They raise profound questions about transparency, competition, and the future of international cooperation. The U.S. Air Force's X-37B is a reusable orbital test vehicle built by Boeing, with 7 completed vehicles so far and an 8th currently under development. Across those flights, the spaceplane has spent thousands of days in orbit and traveled a combined distance of over 1.3 billion miles. Its design is striking, powered by solar arrays, with a payload bay roughly the size of a pickup truck bed. Despite its small size, it's competent, resilient, and demonstrates engineering precision unmatched by most experimental spacecraft of its generation. This level of flexibility gives the craft unique advantages for testing propulsion, materials, and navigation systems. According to official disclosures, the X-37B has carried experiments on radiation effects on materials, small satellite deployment, and advanced communications such as laser relays and quantum navigation trials. On the other side of the Pacific, China's reusable experimental spacecraft, commonly associated with the Shenlong program, has also made progress. Its most recent mission lasted 268 days before landing at a runway in the Gobi Desert. Official reports from China's state news agency described the flight as a success in testing reusable space technologies and conducting space science experiments. Although fewer details have been confirmed compared to the U.S. program, what is known suggests that Shenlong is smaller than the X-37B, but built for similar objectives: verifying re-entry survivability, testing payload deployment, and improving turnaround efficiency for future flights. What makes this significant is that both vehicles are flying more frequently and for longer durations, signaling the maturity of reusable orbital platforms. They are no longer simply prototypes. They are reliable testbeds shaping the next era of spacecraft design. Observers around the world are paying attention, not just because of the technology itself, but because of what it represents: a new benchmark for how nations innovate and demonstrate their space capabilities. One of the most challenging aspects of discussing these programs is determining what is proven and what remains speculation. For the X-37B, a fair amount of data has been publicly confirmed. Its flights, mission durations, and recovery dates are well documented. For example, its 7 completed missions have all ended with runway landings. NASA and the U.S. Space Force have released details on certain experiments, such as material exposure tests and solar-powered propulsion trials. Independent tracking organizations like the Secure World Foundation have also logged their orbital paths, which show their ability to shift altitude and inclination to perform multiple objectives during a single flight. Where the uncertainty begins is with its payload. The X-37B's cargo bay is relatively small, meaning it cannot carry large satellites or heavy equipment. Analysts point out that its missions are most likely limited to technology demonstrations, deploying CubeSats, and testing advanced sensors. Yet, because not every experiment is disclosed, questions remain about whether it could also perform surveillance or inspection of other objects in orbit. What's important here is the lack of transparency. The ambiguity itself creates curiosity and raises broader questions about how reusable spacecraft are being used. China's Shenlong project is even more secretive. However, very little information has been published about what it carried or tested. There have been reports in Chinese outlets that the spacecraft conducted signal relays and released small satellites, but none of this has been independently verified. Observers using radar and telescopes tracked its orbits, showing that it maneuvered multiple times, which confirms it is more than just a passive test vehicle. Speculation has grown from these limited facts. Some researchers in China have warned publicly that the X-37B could be adapted for strategic purposes, labeling it as potentially disruptive. Similarly, some Western analysts suspect Shenlong might test dual-use technologies. But again, these are hypotheses, not evidence. This distinction matters because it affects how the international community reacts. If the confirmed data points to science and engineering advancement, the focus could be on cooperation and transparency. If the speculation dominates without verification, it feeds distrust and raises alarms. The rapid development of reusable spacecraft by both the United States and China has implications that extend far beyond engineering. These vehicles highlight how innovation in orbit can influence global dynamics, reshape the economics of spaceflight, and challenge existing international frameworks. First, there is the technological impact. Spaceplanes like the X-37B and Shenlong are redefining reusability. Instead of single-use capsules or expendable satellites, these platforms demonstrate that spacecraft can launch, operate for months or even years, and then return intact for reuse. This reduces costs over time and accelerates the pace of experimentation. It also creates a pipeline for testing advanced systems such as laser communications, quantum navigation, and autonomous maneuvering, technologies that could become standard on future crewed spacecraft or scientific observatories. Second, there are economic and industrial implications. Reusable spacecraft require expertise in heat shielding, avionics, propulsion, and advanced materials. By mastering these systems, nations strengthen their aerospace industries and inspire spin-offs in sectors ranging from energy storage to robotics. For example, testing solar-powered propulsion in orbit doesn't just advance spacecraft efficiency, it also informs terrestrial applications in renewable power management. Each successful mission builds a foundation for broader commercial opportunities. Third, and perhaps most sensitive, are the questions of trust and cooperation. Because missions like these are shrouded in secrecy, they raise suspicions about intent. One country's advanced test vehicle may be perceived by others as a tool that could interfere with satellites or carry undisclosed capabilities. This perception alone can shape how nations design their own programs and how they engage in international negotiations. The Outer Space Treaty of 1967 prohibits nuclear weapons in orbit, but does not cover many of today's cutting-edge technologies. That leaves a legal gray area that spaceplanes now inhabit. Finally, there's the human perspective. As more nations prove they can build, fly, and reuse spaceplanes, the possibility of an orbital ecosystem grows. Future versions of these vehicles could be used for satellite servicing, debris cleanup, or even the construction of space habitats. But the key question is whether transparency and cooperation will keep pace with innovation. Without open communication, misunderstandings are inevitable. With it, these same spacecraft could accelerate humanity's progress in space in ways that benefit all. What we are seeing today is not the end point, but the beginning of a new chapter in orbital activity, one where reusable craft may become as common as satellites, shaping the next frontier of exploration and collaboration. The story of the X-37B and Shenlong is not just about two spacecraft. It's about how humanity chooses to navigate innovation in orbit. The facts show rapid progress in reusability and long-duration missions. The uncertainties highlight the need for transparency. And the implications remind us that the future of space depends on cooperation as much as competition. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.